Hello finance students, this is Dr. Robinson. So today we are going to be applying our time value of money framework to valuing an actual traded financial security. So corporate bonds are a big part of the investable universe and are big in retirement planning and in pensions and that kind of thing. So just as a broad plan for the lecture, we'll talk about terminology for bonds, explain how we can replicate the cash flows to a bond using securities we already know the value of from our checking account discussion, and then use arbitrage arguments to find a bond price. So then we'll do some practical problems using the financial calculator, and then talk about a few additional issues with risk and inflation. So just to introduce some terminology that we'll need to discuss bonds, there's a transaction that one can do in the marketplace called selling short, and it comes from the short part and the long part relates to being short or long an underlying security. So selling short means that you have a short interest in the security, which is essentially like negative ownership. So for example, let's imagine that you borrowed a lawnmower from your neighbor and sold it. Well, you don't have 0 lawnmowers, right? You have an IOU 1 lawnmower and some cash. So in fact, you have negative 1 lawnmower. In effect, you have a debt of 1 lawnmower. And this can happen fairly easily in real life. You do the same transaction. So you would borrow a share of stock, for example, sell that stock. Now you owe someone a share of stock, and you have enough cash to purchase it back if you needed to. The reason this transaction is interesting is because if the stock price then goes down, you can purchase the stock back at a lower price, return it to the person you borrowed it from with a little interest, and have cash in your pocket. So a short sale is a way to profit when the underlying security goes down. So then you would ask, well, why would anybody ever lend securities under that situation? Aren't they just going to sell and drive down the price of the thing that you own? And the answer is yes, but you do get paid interest. And your individual lending of a share has no effect on the global price. So it's in a sense, a tragedy of the commons, although it leads to more accurate pricing, where I'm interested in collecting my interest payment and my actions don't affect the interest rate, even though our collective actions affect the price of the security. And the reason selling short is important to understand conceptually is because, many reasons, but in particular in our class, as a corporate finance class, we're interested in what companies do, and companies write securities. If I want to raise money, I will write bonds and sell them to the public, which means in effect that rather than a buyer of bonds like an investment fund or pension fund, I, as a company, am a seller of bonds, which means I am short. I have a short interest in bonds effectively. And so I want to sell bonds when the bond prices are high, and as a pension fund or an investment fund, I want to buy bonds when the prices are low. So the incentives are swapped. Companies want to sell high, and that's their first transaction, is to sell. And so we could say raising money in a corporate context is effectively creating short positions, and every time we create a short position on the other side, there's a long position. Okay, so if we think about it, if we look at hedge funds, the hedge funds and mutual funds can sometimes carry this moniker long only. So if I'm a long only fund, what does that mean? Well, that would mean that I am not allowed to take short positions, which says something about the character of fund. Usually it means they're buy and hold investors. They're not really speculating, right? If you're completely disqualifying having opinions on one half of the belief distribution, you must not care that much about beliefs, and you're just investing for the long term. Whereas a long-short fund would buy similar securities, one long, one short, and try to exploit price differences. So these are very different behavior. One very strong opinions on the price of security, and one weak or no opinions on the price of the underlying security. So let's that concept aside, let's think about using time value of money arguments to value a bond. So we're going to start with the simplest of all bonds, basically. It's a French government bond. And the reason we're in France is because this bond has payments, annual payments. Normally, bonds pay semi-annually. We'll get to that in a second, but we want to keep things simple at first. So we have a bond. It makes 4 payments. It has an 8.5% interest rate. And so we have 4 payments of 850, and then we get a return of principal of 100 euros. Now, usually these denominations would be bigger, but if we keep it small, then the percentages match the euros. So we're getting 850, 850, 850, 100, and 850. That's the cash flows we're receiving. Now you can see that down in the total there. That's what we're getting. But to find the value of this security, we're actually going to use 3 different securities, and we'll put them in a portfolio. So the first is a perpetuity that pays 850. So that's in row 1 there. You just get 850 forever. If you remember, the perpetuity formula is cash flow divided by R. So it would be simply 850 divided by the interest rate. So if we have an 8.5 interest rate in the market, we would take 850 divided by 0.085, and you'd get 100. Okay, so that first line would be worth 100. Going to the second line, you can see it is also a perpetuity, but it's delayed. So it doesn't start until year 4, effectively, right? It turns on in year 4, you get your first payment in year 5. So if we're in year 4, we have the same problem as row 1. So we know that row 2 is actually also worth 100, but it's worth 100 in year 4. And we also know that it's negative 100 because we have to pay. Okay, so now why have I created this row 2? Because we don't want to get any money in year 5, right? This is supposed to be 0 in year 5. So if I get 850 from my first perpetuity, I need a negative 850 to cancel it. So the row 1 is worth 100 euros. Row 2 is worth negative 100 euros in year 4. And row 3 is worth positive 100 euros in year 4. Now we know if money is in the same year, we can combine it. So negative 100 plus 100 is 0. And so you would get 100 euros as the price of this bond, assuming a market rate of interest of 8.5% per year. Obviously, if the market rate of interest was different than the first perpetuity, let's just imagine that the interest rate was lower. The first perpetuity would be worth more, right? And the second perpetuity would also be worth more in a negative sense. And so it would no longer cancel with the 100, but the value of those first 4 payments going up will outweigh the second payments going up in a negative sense, and you end up with a more valuable bond. And so this is true generally. As interest rates rise, bond prices fall, and as interest rates fall, bond prices rise, and it's basically because you have a perpetuity which divides by the interest rate. So dividing by a smaller number means a bigger price. So there we go. So go ahead and give this a try, or we'll do it together. So suppose I want to price one of these bonds paying 6% for 5 years and then 106% in the 6th year. What should I put in there? And the answer is a perpetuity starting in year 0 that pays 6 euros, a negative perpetuity starting in year 5 that pays negative 6 euros, and then a lump sum that pays 100 and oh, excuse me, that should be both be year 6, because these are actually 6-year bonds, right? There's 6. It's a 6-year thing, right? 6%, and then 106 in the 6th year. So we have a perpetuity forever, a perpetuity starting in year 6, and a lump sum in year 6. Okay. So now let's do this one. So we have a 13-year U.S. Treasury bond with a face value of $10,000, and it pays a coupon rate of 3.78. The yearly semi-annually compounded interest rate is 2.44%. What is the present value of this bond? Okay, so if you want to do it using the replicating portfolio way, we need to go to Excel. So first of all, we need an interest rate. So our interest rate is, this is annual, semi-annual, and we want semi-semi, right? Because the interest rate needs to match the payment frequency. So that's 1.22%. So we have an interest rate of 1.22%, and then we have payments. In fact, we can even sort of do this similar to what you are used to seeing. Oh, let me slide that over for you a little bit. There we go. Okay. So there's our interest rate, our payment. So if we look at this, it's 3.78%, so that would be $3.78 on $100. So we have 100 times more than that. So our payment is $378. That's a part. So we have $378 payment. And then for how many years? That's our replicating portfolio. So this is a 13-year treasury bond, so we're going to get 26 payments. So we have a perpetuity in year 0. Perpetuity in year 0. We have a perpetuity that starts in year 26, or half year 26, right, because this is a 13-year bond. And then we have a future value, and then a lump sum, which will be the future value. So let's say lump sum / FE. Same thing. Okay, so this one we know is payment divided by R. And this is payment divided by R, but that's in year 26. So we needed half year 26. So we need to take the present value, 1 plus R to the power of 26. And then the lump sum is 100,000 divided by 1 plus R to the power of 26. So now we have our 3 numbers there. And so we do this one minus this one plus this one. Okay, so why do we have a, let's see. So why are we trading under 100,000? Well, so this is worth 30, so there's our 378. Right, so because we have a 3.78% coupon and a 1.22% half-year interest rate. And we have to be careful here. We have to be careful because that coupon should be, we need to cut the coupon in half too, right? We're paying every half year, and so we actually get this. We get half of it. Okay, so we get half of it. Then there's this. And then, in fact, though, because we only have 10,000, we only get 37.8. So we got to adjust that. Right, so this is not 100,000. It's a 10,000 bond. Okay, and let's see. So we've got our payment divided by R, and then we have our payment divided by R divided by 1 plus R to the 26. So that's a smaller number. And then this one should actually only be 10,000. And then this to the power of 26. And then we add those up. And you get this number here. So let's cross-check that with the financial calculator here. So we have a present, we don't know present value, we know future value is 10,000, right? In this case, 10,000. No, right? No, it is 378, right? It is 378 because we take 3.78% times 10,000, right? 3.78% times 10,000. 378 bucks, right? 378 bucks. So we need to get rid of that decimal. But we still divide it in half. So I get a payment of 100. It's 189. Oh, 189. Click here. 189. We have the interest rate of 0.0122. Right? 0.0122. Payment. Okay, we already did payment. The future value is 10,000, and we decided was 26. Right? We can calculate 11,485. See, 11,485.07. 11,485.07. And this makes sense because we're paying a better interest rate. Right? If you look at this, the interest rate is better. Right? We're getting 1.89% every 6 months, and the market is 1.22% every 6 months. So we're getting a better rate than the market, and so we would need to pay a premium to earn that rate. We call these kind of bonds a premium bond. And so that's important. It's a good way to sanity check your work, is you should get a number bigger than your face value if your payment is bigger than your interest rate. Okay, so when we come back, we'll talk, or the next video, we'll talk about how arbitrage arguments work. So we've already done this a little bit when we put those three securities together, right? Those three securities should add up to have the same price as, basically things with the same cash flow should trade for the same price. So if they add up to the same cash flows and we know the value of one, then we know the value of the other. And that's what we've been doing when we did these bond valuation questions just now, was to say, well, let's find the price of the three pieces, and we would get the same price as if we would just buy the bond. If not, we could make a bond, we could replicate a bond using the pieces. And this actually is something that occurs in real life. So I heard a lecture from a professor at Carnegie Mellon, Dr. Chester Spat, and he worked in industry at a time when Nabisco was distressed or going through a corporate restructuring of some kind. Point was their bonds were trading significantly below face value because the company was a bit in trouble. But what they discovered was that Nabisco had many, many different bonds out in the marketplace, and they were all trading as if the company was going to, had a chance of being in trouble. But the different bonds had different prices on the trouble. And so if you took one bond that valued the trouble as being more serious than another bond, you could take a government debt, combine it in a portfolio with one Nabisco bond, and create another one for less money. And because it's the same company, anything that affected the one bond would affect the other in exactly the same way, right? If one gets in trouble, the other's going to get in trouble in exactly the same degree. And this was a pricing discrepancy that resolved itself fairly quickly, and they made many millions of dollars trading on this strategy. So every once in a while, these things crop up. Not so much anymore because we have computers who watch for them like a hawk and buy them up quick when they exist. But it's an important mechanism for preserving the orderliness and the price accuracy of the marketplace. Now, I've been using arbitrage arguments to price these bonds, but the truth is, when you do your work, you're probably just going to use the calculator because it's faster and easier and less likely to cause trouble. But as you saw, right, both approaches work just fine, and in fact, using the calculator implicitly assumes an arbitrage argument because the calculator breaks it up into chunks just like you do if you do it using the formulas in Excel. So yeah, point is, using the financial calculator and skills you have already, you should be able to tackle bond problems without too much difficulty. So you have enough to get started now, and then when we do arguments next lecture, it will help encapsulate all of the thinking.